Hello, everybody. And for some of you, welcome back. I'm very pleased to see I've got some repeats from this morning. So my name is Nazar Bina, and I'm going to be doing the biological imperative for intelligent content. So those of you who didn't meet me this morning, that's me. I'm a newly independent content strategist, trainer, and founder of Urbina Consulting. We're just actually rounding off our first year. Yay. And that's been going well. I am co-author of Content Strategy, Connecting the Dots Between Business, Brand, and Benefits, who I wrote with Rahel Ann Bailey, who some of you may know. And I tend to specialize in the kind of things that this conference tends to specialize. Large organizations who are doing mainly B2B, complex devices, medical devices, telecommunications, microchips, and so on. But I am working at it in a very cross-silo strategic way. I work in technical communications very frequently, but I am also trying to work with other types of communicators within the business to see how overall we can do better for the customer. The problem with that is this. Not Google Glass specifically, but the fact that there's always seems to be something new. And if you are a large organization, and you do have complex content, especially complex regulated content, then adapting to all of these various new formats and new ways that people need to consume can be a very expensive and long process. So this whole presentation, in a way, could be said to be a case study in empathy. What I'm trying to do is understand people and understand what's happening in the market so that we can stop reacting to what's happening. As technical communicators and as communication departments of the business, we can often be underfunded or at the tail end of the process. And then when something comes along, we have to react to it once it's already hit mass adoption. But this could be a multi-year journey of learning these new skills, migrating the content, choosing systems, implementing the systems, rolling them wide out across the organization. You could be talking about 5 years, by which time 2 new formats will have hit you. So how do we get out of this constant loop of catch-up? And that's by moving to an anticipation model. Sorry, I have a little sigh of sadness there. Because I've seen it so many times, people who are stuck on PDF, stuck on printed pages, and then something hits them from the side when the market turns it up, and we have to up our game. So this is actually the culmination of about 2 years of research. I have read all of these books. You'll see there's a diverse background here. Some of them are in behavioral economics. Some of them are molecular genetics. Some are about particle physics. But I felt all of these led me to the conclusions that are in this presentation. I also watched a huge number of TED Talks. And I found out that you can go on this website, which I discovered called YouTube. It's really cool, you should try it. And you can attend lectures from MIT and Stanford for free from your house, which is amazing. So you can, I've sat in on some of the cognitive science and behavioral anthropology lectures there. And I've had the slides, my original creations and models in this, and the drafts reviewed by a clinical psychologist, Alberto Soler, and his wife, Conchine Soler, who is a PhD in psychobiology, to make sure that I'm not saying anything outside of what I should be saying as someone who doesn't have their PhD in this area. So my thesis here, to influence behavior, we must understand behavior. And behavior starts and ends in the mind. We need to be constantly redefining. One of my favorite books from all of this, and one, if you're in communications of any kind or in content in any way, James Gleick, The Information. It's fantastic. History of, from African drumming to Twitter, how communication has evolved and what the basics of the fundamentals are that are universal across cultures and history. And in it, he talks about Isaac Newton And Isaac Newton had to redefine various words. Mass, force, time, motion. All these words mean something to us because Isaac Newton took them from the vocabulary and said, I'm trying to describe something very specific, so I'm going to have to give this word a new and specific meaning that it never had before. My favorite example is motion. A peach that was becoming ready to eat was in motion. It was just kind of a loose word for a change of some kind. And then Isaac Newton said, no, this is what motion means. And from that point forward, that's what motion meant. And he was doing that because the world was changing, and how he was trying to describe the world was changing. And I feel that we are in that same position. We are redefining things, and we are inventing new vocabularies because we're having to discuss concepts we've never had to discuss before. So, topic is the communication in the mind. And the thesis is that intelligent content supports our biological mental processes better than traditional content. So intelligent content I define as content that is modeled, semantic, rich in metadata, and able to be machine processed. And traditional content, I mean unstructured content, as we would traditionally write it in word processors, unstructured tools like Unstructured FrameMaker, HTML as a native format, and so on. So it's kind of a counterintuitive thesis, because you would assume that what we are most naturally good at, that which requires no training, we can just all do, that would be the best thing for us. And what I'm saying is the reverse. So I'll start with how we make sense of the world. And all the research I did said one thing, that we are sense-making machines, and we will make it up if we have to. So I start at the beginning. And when we come out, our brains are thirsty for this information. We start this process very, very early. And there's a great thing, I think it's also in the information or possibly in one of the other books, which will come up later, where they're showing pre-verbal infants, so babies that don't talk yet, these videos of a red square and a blue triangle. And the red square is bashing against the blue triangle, and the blue triangle is kind of moving away from the red square on the screen. And they hook them up to these sensors, and they can validate that the baby is rooting for the blue triangle, and he hates the red square. Because he's already kind of, or he or she has already developed this model of the strong and the weak, the oppressor and the victim. And they identify, of course, with the victim, being a little baby. So semantic models are something that our whole perceptual landscape is made out of. The way that we see and interpret the world uses semantic models as its base unit. They're what you can call a semi-conscious mental storage unit. I use the stoplight example there because we can go all around the world, and specific stoplights will look a bit different. They'll have different symbols on them. They may not have bicycles on them. They may be different sizes, different positions. But we all understand a stoplight. We get it. And there's a reason that there's so much standardization around core elements, because you cannot afford to roll up to a stoplight and go, I know that means something. So a stoplight is a perfect example, because no matter how much you change it, the core essence of what a stoplight is universally, instantly retrievable. So that's how semantic models play out in our day-to-day life. And if you want to make a baby cry, you can do a few different things. You can deny it food or sleep, or make it feel some sort of physical discomfort. Or you can try to play a board game in front of it. You can try to all participate looking at a puzzle together and not include it. A 3-year-old will self-destruct in that situation because they are suffering against their own biological imperative in the same way that they're suffering when they're not eating. They have to build their semantic models. They were born on a mission, and you can see the stages in our development. They're born in a mission to gather input, model the whole world around you, learn how these models interrelate so you can be ready for life. So at that stage, when you're saying, this is for us, not for you, and they go nuts, That's because that's the stage in their biological development that they're at, and you're denying them a basic biological need. They need to participate with us. They need to see what we're doing, and they need to figure out what are stoplights, what are toys, what are all these activities that I'm seeing around me. So we do that from the very beginning. But how good is the result? We're going to do a quick quality check. So I'd like you to raise your finger. You see the dark square and the light square? Put your finger on the line between them, just like that. You can do it. Come on. It'll be fun. So what you should be getting pretty quickly is that the dark square and the light square are no longer the dark square and the light square. Is anybody not getting that? Yeah. So you can do that as many times as you want. You're never going to learn. We just can't do it because certain things about our perception are baked into a level where we can no longer have conscious control of them. But there's all sorts of things going on like that. But we've established here that our models and our processing clearly aren't perfect. We don't have an exact representation of the world in our head. And this is where I get back into cognition and thinking and interpretation. And this is the other book that you must read. This is by Daniel Kahneman. It's called Thinking Fast and Slow. And it talks a lot about the brain economics, the cost-benefit of cognition. Daniel Kahneman won a Nobel Prize in economics, even though he is a cognitive scientist. Before, when we studied economics, we had models that we built from our intellect that said, given all the relevant information, a human being will make the rational choice in their own best self-interests. What Daniel Kahneman proved was we're not all that rational. Given a choice and certain defaults, we are predictably irrational. Example is a mortgage. The bank says, how much can you borrow for your mortgage? And they'll say, you can borrow a maximum of 40% of your income. So traditional economics would say that each person is going to evaluate their financial situation, their current debt load, their projections in life, et cetera, and they're going to come out with the right mortgage for them. What generally happens is someone goes, okay, how big a house can I get for 40% of my income? So the defaults that we have influence enormously, and they are coming from these two systems that Daniel describes in his book. The first system you have to understand, system 2. Our system 2 brain is our slow, expensive, and tiring brain. This is our thinking when we play poker and chess, unless you're a chess master, and then you can use system 1. It contains our conscious experience. So it's who we think we are in our day-to-day life. And it does all our analysis, reflecting, and it digests content that we read. It's taxed when learning new skills. People always tell me, especially in North American conferences, how tired they are by the end of day 2. And then they're totally exhausted by the end of day 3. And they keep going, why are conferences, why is sitting in a chair looking at a screen so exhausting? And that's because system 2 is operating all day long for 3 days. We're not used to that much new information that we have to digest. And so it's exhausting. It's actually brain and physically taxing. Which is why system 2 delegates to system 1 whenever possible. That's the part of our brain that is fast and cheap and nearly effortless. That's the part of your brain that understands a stoplight. So it is the zone. When people get in the zone, or when they're thinking from the gut, or making decisions from the gut, or the heart. But it's also lateral thinking, when you make free associations and are able to be inspired. And that does actually some very beautiful things. So it plays the violin, it drives a car. Anything that you've learned to do to the point where you don't have to think about doing anymore, that's system 1. I like to kind of build up system 1, because if you look at some presentations on this topic, people have started using Mr. Spock from Star Trek and Homer Simpson as the symbols for system 2 and system 1, like the rational and then the spontaneous and irrational. That's dumb and oversimplified, frankly. System 1 is beautiful. System 1 does body language. It picks up on style, mood, metaphor, symbolism. Some very, very complex things about our very human nature. It's not just this reaction engine. It has all of our semantic models, and it's able to make free associations in ways that our conscious brain doesn't allow us to. It uses a lot of compression in semantic models. And when it comes to content, it skims. So system 1 is the one that learns the layout of pages. System 1 can roar through 100 pages of encyclopedia to find the one entry that it's interested in. Because it knows the layout of the page, it gets where everything is, understands the table of contents, and is able to dip in and out at that speed because it's built all those semantic models and it no longer has to think about them when searching for the content. Then when you get there, system 2 engages and starts analyzing what you found. So this is where the two live and what they do. I'd like you to feel the difference quickly. So answer these in your head. What's your first name? What month were you born? Now remember these two number sets. I made one of them easy, a double number in there. Now add 1 to each digit. Okay. Did anyone get this? Yeah, okay. That effort spike that you felt, whether you got it or not, you felt the difference. That's system 1 handing over to system 2. And they will hand back and forth all day long. And whenever they can, they will prefer system 1 because it's less effort. So this is a different kind of illusion. And this is one that kind of freaks people out. There are 3,141 counties in the United States. All of the counties with the lowest incidence of kidney cancer are mostly rural, so small towns, villages outside of the big cities, sparsely populated, traditionally Republican or right wing, located in the Midwest, South, and West. So immediately we start to kind of see why that kind of makes sense. All the counties with the highest incidence of kidney cancer are mostly rural, sparsely populated, traditionally Republican, and located in the Mid, South, and West. So what's going on there? So if we take, if we have one, this is a random series of ones and random series of 1 and zeros. If we take 1 equals cancer, if we take a larger sample set, we will always get less extreme results. So if we move these boxes, we've got 28% here and 60%, 71 and 0, 42 and 100, and 57 and 60. So bigger box means less huge jumps in the numbers. That's always true. Small samples are always more extreme and always less accurate. But intuitively, we started making sense of the data that we had. And you've got people who are thinking about when the cancer rates are high, that they're eating fresh farm food and they're away from the pollution of the city. Or if you show them the other numbers first, they start thinking about people eating pig lard all day, riding around in tractors. But we make sense of the information, which is a cognitive illusion. What you're doing is you're taking your own bias and you're building sense when there is no sense. Because mathematically, the only thing that had to happen for those numbers to come out that way was sparsely populated. That's the only thing that mattered on the whole list. Once you know that both the highest and the lowest are always going to be there, because that's where you get a small group. Small groups mean extreme results. The Bill Gates Foundation and the US government blew millions on this because they discovered that the best schools were small schools. So they actually invested in breaking up schools and making smaller schools, and neglected to notice that the worst schools were also small schools. So professional statisticians screw this up. We kind of want to, In his book, Daniel Kahneman noticed that a majority of professional statisticians don't apply the math that they know they should apply to set their sample size properly. They go with their gut because they've been doing it a while, so they trust themselves. We have a tendency to do this, and in content, we can't. So I'm going to summarize. System 1 can read and understand large print and familiar words. It can complete phrases like bread and. It gets which country is referred to by stars, stripes, apple pie, and optimism. And it can find the submit button on a form. You know, we don't look at the top of the form once we got in the bottom. System 2 can try to reason out the meaning of new words, drive in heavy traffic or adverse weather conditions, or search for an address on a row of houses. It also can compare two products to establish their overall value, two features, two options in a task. That's all System 2 work. So I've got a little diagram here. Anybody know what it is yet? No? Yeah? It's a face. Obviously it's a face. But it's kind of not. It's really not. So System 1 is using compression to take the fundamentals from the right and match it to the model on the left. These are the keywords here. Compression creates errors. We see what's not really there. So we did it with the cancer example. This is doing it visually again. So how does that apply to customer experience? We're going to look at experience versus memory and compression error illusions. So I've got some more studies here. I've got who suffered more. I've got patient A. This is their pain over time. They said that they suffered an 8 out of 10 in pain over about 9 minutes. And this is patient B. They suffered about the same and even longer. So when asked who suffered more and who would repeat the experience more readily, and the one who suffered more was, of course, patient A. The reason that they suffered more is because their pain suddenly stopped, whereas patient B's pain slowly tapered off. So what they remember is that, yeah, it hurt, but then it got better. Memory, sorry, were you seeing that the whole time? Yeah, okay. So memory trumps experience. Memory is more important than what you are actually experiencing in the moment. So this is very important for customer experience. When we're thinking about what customers are going to experience with our content, we actually are looking at the wrong thing. It doesn't matter what they're experiencing moment by moment. It matters what they remember after the fact. So Daniel Kahneman says, the remembering self is a storyteller. What we get to keep from the experiences is a story. And what defines a story are the changes, the significant moments, and the endings. You can all imagine the example of listening to a piece of music, and at the end of the music, there's a big distortion in the recording. Or when this story was originally told, there was a scratch on the record. And it ruined the whole experience. That doesn't make any sense. Why does a quarter of a second of ruin 5 minutes of beautiful music? Because that's how our brains work. We squish that whole experience down, and it's the end that matters. Endings are very, very important. Technical communications is very often the ending. So when we're going through a customer journey and we're very excited about customer experience and brand and how we're speaking to customers, and then we hand them off to technical communications and we leave them underfunded, without proper resources, without proper tools, and not integrated into the rest of our process, we drop the ball at the ending. We drop the ball at the most important part in the customer's journey, because they're going to remember the end, not all that experience that got them there. They're going to remember the part that we control. I have an example from my own life. I was on a flight with Delta Airlines. I don't know if that means as much here as it does in other places, but Delta Airlines is not the best loved brand going. And I had a fantastic experience with this airline, to the point where I actually wanted to bother to give them some positive feedback. And then I tried to go on their website and I found this, the comment/complaint form. So when people were looking at their content requirements and they were looking at the user journey and the process, somebody said they need a way to put in comments and or complaints. And somebody came up with this and they went, check, fine, job done. They did not think about the full customer journey and how it was going to end. And they didn't think about it in the reality of their real world. They looked about it from at their own perspective in terms of ticking the boxes and producing the content that they felt that they needed to produce. What happened was, you get off the plane, I go on my phone, because I'm not going to keep this idea in my head until I get to a laptop. So I go on my phone, and that's the form I actually get. It doesn't fit on a phone. And then I have to fill out all this, like it goes on for like another several steps before I can give them a compliment. So of course they didn't get their compliment. And it went from my positive Delta experience to my example at conferences about how crap Delta are. So dropping the ball at the end, not looking at the whole customer experience across departments and across handovers, leaves you open to this kind of mistake. Okay, so I put all this together, all this research together, into what I call the experience to identity pyramid, the semantic ladder for anything with interactivity. So we have experiences. We have lots of experiences in our lives, and then we store memories of those experiences. We start to establish patterns from those memories and categorize those patterns. From a category, we then can build a model and eventually an identity. So I'm going to take you through that because it's not very intuitive just like that. So on a regular basis, I have friends that I see, stuff that I do. One of these friends is Jerry. Jerry and I go out and we get very, very, very drunk. The next day, I'm going to have a bad memory because of how that experience is going to end. If that happens several times, I might detect a pattern. And I might categorize that under things that I shouldn't do. And my model for how I spend all my time and how my strategy for planning my life will take into account all those different categories of things. And eventually, that's going to impact the identity of Jerry. So we've gone from, I got drunk with Jerry, to Jerry's a jerk. And that's how customer experience works. We have thousands of different little interactions with the organization. And they all get added up to an ID in the end. Brand identity is the sum total of all these different things. If we're focused only on here, and we somehow think that's going to get us up to here, without addressing anything in the middle, then we're seriously missing a trick. We have to look at the whole ladder to see how all these various experiences are going to add up. As we get up the ladder, we have easier access. You'll remember an identity much more easily than an individual experience. You get much more compression, so you're going to lose all that detail. It'll all be disposed of, and you're just going to keep the essentials. And you get more rewards from the brain, which I'm going to tell you about in a second. And an important one, more inertia. So how stable and stuck this identity is more impactful when you have gone to the point of developing an identity. If you have an experience and you have an established picture of someone or something in your mind, one experience is not going to change it. It's going to be quite stable and resistant to that. If you have few experiences, then there's more chances of it affecting the identity. I'm going to, for time, go 2 slides further forward. Huh? Yeah, I know. OK, and come. OK, here. So I mentioned the word rewards. When we use these models, when we're able to leverage these models or create these new models, whenever we're working with models, the brain will decide whether it's going to give us dopamine or not. Dopamine is our brain's reward chemical. When we do something that our system wants us to repeat, we get a dose of dopamine. If you create a new model or a new identity, you get a little dose of dopamine. Meeting a new person, learning a new skill, understanding a new concept, we get a little brain reward for all that. However, there's a shortcut. If you can use a reward if you can get a reward by using an existing model or relating to things. For me, one of the most powerful examples is metaphor. I still can't get over metaphor because I'm trying to explain a complex concept for you in techno-communication or content modeling, and I'm going to talk about ducks and how they go to the lake to get food. They're totally different things. They're completely irrelevant. We have the metaphor for finance about the squirrel who keeps all of his nuts throughout the year. We're not squirrels. But we get that. So we're able to laterally take two things and compare them, and suddenly, by reusing an existing model, we can shortcut the whole process. We want to make sure that people are efficiently moving through all their experiences, having good memories, and we're rewarding the right things so that we get a good, solid brand identity in the right way. Because the question of this whole presentation that you need to leave this session with is, how is your brand going to stand up to compression? When you take away all the little variances between this department and that department, the overall customer experience, what are they going to walk away with? And where are the problems? That's what we have to address. It's inherently cross-silo. We don't care if it's tech doc's fault or marketing's fault or the salesperson's fault or the product itself. We need to be looking at that whole thing and saying, at the end of the day, this is going to affect our identity as a company in the customer's mind. So let's track their experience and build properly for it. Do that well, and you can have a very, very powerful brand identity. An almost kind of scary, godlike brand identity, where you can't talk about them as if they're a real company anymore. They're like a supernatural entity. So if we manage our consistency properly, we can build something very, very powerful like that. Intelligent content is the way that we manage that consistency in content. So it enables agility from experience to identity. So intelligent content is very good for the whole experience to identity pyramid. Intelligent content is free from format. It takes messages and meaning across devices, across different styles. Our mind compresses out details, like were we using a tablet or a phone when we access the content, or were we using a laptop? We don't care the next minute. We care what the memory was, whether we got the knowledge or not. So we want to be able to do any of them and get the right result. It's rich in metadata and uses tagging to make associations by metadata. So all these things are tagged for gold customers. All these things are tagged for engineers. The mind is associative by nature. That's how it works. It builds up categories of all these experiences and uses that to guide our lives. Intelligent content uses structured content models. The mind operates on models. All of our perception is filtered through our models. Intelligent content is machine validation ready and reusable to make diverse yet consistent stories. The mind likes finding patterns and consistency. When it can leverage an existing model, it's happy. It feels it's done a good thing because it's been efficient in its processing. It gets tired out by needing to parse inconsistency. When you have inconsistent terminology, inconsistent structures, inconsistent ways of delivering information, system 2 is going to try to find meaning. Why is it inconsistent? Why is there a difference? My favorite example, I can't name them because they're an exhibitor here, but there's a very big company who sells a conference product, web sharing tool. And if you look at the top of the interface, it says speakers, because it's referring to the person who's speaking. At the bottom of the interface, it says presenters. There's no reason, and they haven't fixed it in 3 years. I literally got screwed up by this because I was looking at the thing about speakers thinking it had to do with mono versus stereo and something to do with the sound because it said presenters at the bottom. So it can't possibly mean the same thing at the top of the same window. So inconsistency, 2 different teams working on 2 parts of the UI, 2 different departments working on the same document, 2 different authors who are consistent in their structures. All of this will waste system 2's time. Excuse me. So applying this, we can see that modern tools and platforms are getting better at leveraging these concepts. On Twitter, when you look up a hashtag, that's a hashtag, by the way. Seriously, there's a lot of people who don't use social media. So, oh, sorry, no, that's a hashtag. I didn't have my mouse there. So this is a hashtag. So you can look up this tag for people's social media posts. In Twitter, you'll just get a list of all the things tagged as that. In Google+, you get that as the top tag and then related tags. So associated tags. From that general subject area, it will allow you to drill down and explore laterally. Content modeling is something I mentioned in my previous session. It's one of the things that I think is one of the most important and understood disciplines out there right now. Content modeling is where we're taking the model from the actual instance. So we have a content as we know it, and we explore it, and we break out its logical skeleton. So we have a title, win title there, that's over there. Short description is that bit. Overview is over there. And then screenshot and shortcut. When we were just writing it, we could have done them all with two styles. Title, body. The content model allows you to do much more powerful things. It allows you to say things about these parts of the document. Where are they supposed to be? Which ones go inside which other ones? How many of them are supposed to be? From a brain science point of view, your creators and your customers will internalize these models. System 1 will learn the models of the content, whether you're writing the content or whether you're reading the content. Because you will get used to reading these documents over and over, and you will move through them much faster. In the same way that we can move through a dictionary so much more quickly than we can move through a novel, anything with structure to it enables System 1 to skim and scan and navigate. Cheaper for the brain. And as I was saying, we can then map that metadata to other rules. And we can put rules on the rules. And we can say that, where's my mouse? Okay. What type of content is it? It should always have an image in it. How many of them do we need? Is it mandatory or not? Is it boilerplate? And then we can map those things further and say that in the PDF manual, we do want the little screenshot, but in the online help that's going to be next to the actual interface, we suppress all the screenshots. You can do that from the model point of view. So from a machine point of view, you can control that just by talking about the model for content that's never even been written yet. Your team will internalize it, your customers will internalize it, and you can use it as a contract with all the other departments. So they can develop templates and publishing outputs and automation algorithms to operate on these. I'm going to do probably the fastest intro to linked data and RDF you're ever going to see. The reason that I'm bringing it up at all is I see linked data and RDF and OWL2 as teaching computers to think like we do. I'll get a little bit of a thank you here to Pavel Kowaluk from Motorola Solutions. We worked on some of these slides together. He's a fellow Data Geek. RDF is a family of W3C standards. It's a metadata data model. So it's a data model for describing metadata in specific. And it's a variety of notations and formats. It's used on the web and in knowledge management to help us organize content sets. Basically, the way it works is RDF defines statements, logical statements. For example, something relates to some other thing. With traditional content, you can say that this file has a hyperlink or a cross-reference to that file. It's a one-to-one link. But what RDF brings to the table is this bit. It makes the link itself a thing, something that we can add metadata to. So RDF is a type of content standard. There's no way to do an is type of cross-reference, an is type of hyperlink. That doesn't exist. It's not an existing concept. RDF allows us to create special relationships. And that lets us do really cool stuff. Like say we've got a printer. It's called image class. And we'll say it is a type of printer. It has a USB antenna. And then from these relationships, make more relationships. Rich relationships amongst all the different categories of things we have. So from USB antenna, we can say that is a type of part. Part has a part name. it has a color, and it has files, which are about that part. So nobody doesn't get this. Like, it's incredibly simple, because all it is a W3C standard for giving computers the same perspective on the world that we have. But what's powerful about it is instead of relating files directly, you can relate tags directly. And files then become related as a side effect. So you can make an association between files to the part to a whole classification of parts. Or you can look things up by part name and then go get back to their files. You can go 3-4 steps down the chain and have search engines which are able to understand and drill through these types of relationships. Whereas now, we have free text search. If the text is found, then show it. Or we have social enablement, where if lots of people looked for it, then show it. But this is why we can't look things up in an intelligent way, because it's not actually understanding the things. And what RDF and OWL are for is helping them understand. So it can get a model in the computer the same way that we do. At the end of the day, we have a simplified model in content modeling and in RDF and OWL of a complex reality. These are to this as this is to this. And if we build properly for that brain-based view of the world and put that in the computer, then the computer can do all sorts of intelligent things that it couldn't do for us otherwise. Intelligent content supports tailored delivery. We want to go out to all these formats. We can create our components in structured authoring tools, manage them in a structure-aware system that understands the real structure of our content, understands the models of our content and how it relates to each other. And then we can serve it and transform it with processing tools to whatever format it is we need. We can give it to everyone on all those formats, or we can be very specific. And we can take little bits for the right situation and the right profile of person and give them only what they want. Because the computer understands the content in a deeper way and can reach in and pull out all those different aspects. The web ontology language, OWL, has been a standard since 2004. No one cared. It was a tiny little thing happening off in the corner of the web. No one cared. No one cared until enough content and enough businesses hit a level of complexity that they needed to come back to it. They needed to come back and say, okay, free text is not good enough anymore. The other systems that we're using are breaking. We need to do something a level above, which is now why Google, Bing, Facebook are backing this standard. So I'm just wrapping up. So now your system one does everything it can to restore the status quo. Unfortunately, this is how we function. I said, new ideas are brain expensive. So this is probably one of the most costly sessions you're going to attend today, possibly at this conference. So you have to do some homework. Embrace intelligent content. Think about system one and system two. What kind of thinking is the person going to have to do? What situation are they in? How are they going to interact with your content? And how much cost are you going to put on them? Explicitly define the semantic models implicit in your content. So model your content. Don't just create templates for an authoring tool, but think of it logically outside of all tools. How does our content work in and of itself logically? Map out the different perspectives and contents where that content will be used, and figure out which part of the models are appropriate for which situations and which kinds of users. Give creators clear tools to create and visualize their work across contexts, and store semantic content so machines can validate it and help you deliver tailored experiences. What this is essentially about is not learning new technologies, not learning new tools, but realizing that we're trying to put the humanity back into content. We're trying to make content more like we work internally, because right now we're losing all that once we put it onto the page. Okay. Measure user memory of whole journeys, user experience, and all, as hot as it is, that's just a means to an end. That's what they take away that matters. Analytics and digital cannot show you the full customer experience. Think about where they are. Is it cold out? Are they wearing gloves? Are they angry? All this stuff matters. Set up your team properly. chief content officer, chief experience officers, they're becoming real things in the industry. So look at the roles. Get content creators, strategists, and engineers, and everybody else who understand the value of everyone else's work. Because I said this is by definition cross-silo. And start bashing on your boss's System 1 and System 2. Thank you very much. So this is the scanner code for the feedback form. Your feedback is extremely appreciated. And I think we have some more slips. If you don't want to scan it right now, you can scan it on a little paper on the way out. Do I have any time for any questions? No. Can I do one? One question. No? I get much less questions after this session if it's after lunch. Okay, thank you very much.